Hi. This is an instructional video on how to use Tintype Text to convert your scanned typewritten image files, in JPEG image format, into rich text format documents. There are 4 different Python code files that are to be run in sequence, although only the fourth and final file, getPredictions.py, would be necessary if it were run using one of the deep learning models that I have trained on my typewriters. See the Google Drive links in the description to find the models for the 2021, Royal Epic, and 1968, Olivetti Underwood Letter 33 typewriters. The Python file, getPredictions.py, as its name suggests, will allow you to perform optical character recognition, or OCR, on your typewritten image files, and convert your typewritten text into digital form as a rich text format, or RTF, document. Here are some important pointers when performing OCR. The typewritten pages need to be scanned in JPEG image format at a resolution of 600 dpi, and the JPEG files need to be placed in the OCR raw data folder. Also, all of the JPEG file names in the OCR raw data folder must contain at least one hyphen in order for the code to properly create subfolders in the OCR predictions folder. These subfolders will contain the RTF OCR conversion documents. The reason for this is that when you will scan a multi-page document in a multi-page scanner, you will provide your scanner with a file root name, for example, mytext-, and the scanner will number them automatically, mytext-.jpg, mytext-1.jpg, mytext-2.jpg, and so on. The code would then label the subfolder within the OCR predictions folder as mytext. The OCR prediction results for each page will be added in sequence to the mytext.rtf file within the mytext subfolder. RTF documents are like text files, but with added formatting information, such as text alignment, paragraphs, bold and italics. Simply double-click on the RTF file in order to open it with your word processor. As you can see, when comparing the typewritten image with overlaid character rectangles with the RTF document, some words, tintype and rich, were not correctly converted into digital form. The bad OCR results were obtained because of poor segmentation, or staggered character rectangles. Bad character segmentation could be observed if your typewriter has a lot of ghosting, faint outline of the preceding character, or if the signal-to-noise ratio is elevated, because of high ink loading on the ribbon, leading to lots of ink speckling on the page. The segmentation code might then pick up the ghosting or noise as characters. As a result, you could then end up with staggered character rectangles. In the presence of dark typewritten text, you should decrease the segmentation sensitivity, increase the number of non-white Y pixels required, for a given X coordinate, in order for that X coordinate to be included in the segmentation. That is to say that on a fresh ribbon of ink, you should increase the value of 3 to about 6. Results will vary based on your typewriter's signal-to-noise ratio. In the line 57 of getPredictions.py, in order to avoid including unwanted noise in the character rectangles. After decreasing the segmentation sensitivity, we can now get the updated scanned typewritten image overlaid with character rectangles, by deleting the previous OCR predictions subfolder, and running the getPredictions.py code once more with the decreased segmentation sensitivity. Notice that the problematic words, tintype and rich, are now properly segmented. As the character segmentation is now well aligned with the actual typewritten characters, the OCR results within the RTF document accurately convey the information found on the scanned typewritten page. For an in-depth explanation of all the most common RTF commands and escapes, allowing to include formatting elements in your RTF document, please consult the link in the description. To keep things as simple as possible in the default basic RTF mode of the getPredictions.py code, the use of curly brackets is disabled, and the paragraph RTF command, =par, is changed to \par, \d, after OCR. An equal sign is used, as there are no backslashes on typewriters. This means that the paragraph formatting attributes, such as centered alignment, QC, in the first line of the scanned typewritten image, are returned to their default values automatically, when a new paragraph is started by typing =par on the typewriter. In the Advanced Rtf Mode, the use of 2 successive parentheses is translated to curly braces. Also, =par is simply changed to \par in the Advanced Rtf Mode, and not to \par, \d, as in the basic Rtf mode. This allows more flexibility, and the use of the curly brackets already limits the scope of the RTF commands, so there is no need to have a \par d added automatically. In order to activate the Advanced Rtf mode, head over to the getpredictions.py code and search the code file, using Ctrl F, and looking for Advanced Rtf Formatting Mode. First, the 5 last lines of the default basic RTF formatting mode, right above, need to be commented out, that is to say that you need to add a hashtag symbol before each of these lines, so that they are not recognized as code by Python. Then, the hashtags preceding the 5 last lines of the Advanced Rtf formatting mode must be removed, in order for getpredictions.py to run in the Advanced Rtf mode. The Python code file is then saved, and the getpredictions.py code can be run on scanned typewritten files, typed with the Advanced Rtf commands. You can notice that the results are largely the same, but that the advanced mode enables you to use more diverse RTF commands, such as superscript, subscript and small caps. And that's it. You're now ready to convert your typewritten manuscript into digital format. You can now type away at the cottage or in the park, without worrying about your laptop's battery life, and still get your document polished up in digital form in the end.